I'm going to walk you through a step-by-step approach to a stoichiometry problem to show you just how very easy stoichiometry really is. It scares the hell out of chemistry students, but it's not hard. Not really. Now, stoichiometry is a way for a chemical engineer to predict how much final product they're going to get when they put together various reactants. And it's really not hard. Simple arithmetic. I want to walk you through it. Here's what I think you should learn from this. First of all, you're going to figure out what is the correct ionic compound formula for the various reactants we're putting together, how to know if you have a balanced or unbalanced equation, what are the ratios between the various components in the reactants and the products, how to figure out the molar mass of the various compounds, and how to figure out how many moles you have, and then how many moles of final product you have, and then finally, how much does that weigh? How much mass do you have at the very end of all of that? First of all, let's assume that we're going to put together barium nitrate and sodium hydroxide, and we're going to get barium hydroxide and sodium nitrate. The tools I'm going to be using to show you this are the Ionic Bond Disc Model and the Ion flashcards. The links to both of those are in the notes. So let's get started. So we're going to put together barium nitrate and sodium hydroxide to get barium hydroxide and sodium nitrate. Let's start with the flashcards. So sodium loses 1 electron here, becomes +1, and hydroxide has a charge of -1. Okay, so you have a +1 and a -1. They just go together. No problem. Final formula is going to be NaOH. Barium nitrate, on the other hand, has a charge of 2+ because it loses 2 electrons. Nitrate is a polyatomic ion made up of a nitrogen and 3 oxygens, but it has an overall charge of -1. Well, those don't match up. This has to be -2, but it's not, it's only -1. So we have a problem, okay? Let's look at the Ionic Bond Disc Model. I think it'll make it much easier to understand. Here's a barium, and it's got a charge of 2+. It loses 2 electrons. And here's a nitrate, -1, and 1 will go here. That's straightforward. Let's get another nitrate, and 1 will go there. So we have barium nitrate, BaNO3. 2. There's 2 of these. Simple. Okay? Now, sodium hydroxide, +1 and -1, and they go together. Again, simple. Now, if we look at the reaction, however, starting with this, these are all going to come apart in the water. Anything with a nitrate will dissolve in water. Anything with a alkali metal like sodium will dissolve in water. So this will come apart, right? So we'll end up with, and then when hydroxide gets near barium, it doesn't like the water. It'll fall out of the solution. But wait a minute, we're left over with a +1 here. And, well, we'll have 1 with the sodium, and we're left over with a nitrate. This is not a balanced equation. You don't get barium hydroxide then because we need to have an extra hydroxide. So we've got a problem here. Okay? So we need to have another sodium hydroxide in the mix. Now, this one will come apart. Here's an extra sodium hydroxide. It'll come apart, and it'll go together like that. It'll fall out of the solution as barium hydroxide, and that leaves us with this. So now we have 1 barium, 2 hydroxide, it's BaOH, parentheses 2, and NaNO3, and there's 2 of those. Okay? So now, if we look at the reaction total from the beginning to the end, we're going to start with barium nitrate. Let me take this apart so you can see it for yourself. Oops. So we'll have barium nitrate. We'll have 2 like that, and we'll have 2 of the sodium hydroxides. So we have 1 of these and 2 of these. We have a 1-to-2 ratio here. Now these will come apart. This will come apart. These are all floating around in the solution together. And then the hydroxide happens to come there, and another hydroxide comes there. It falls out of solution, and that leaves us with 2 of the sodium nitrates. So again, we have now 1 of the barium hydroxide and 2 of the sodium nitrates. So now we would have a balanced equation, and our final ratio would be 1 to 2 to 2 to 1. For the purpose of explaining this, let's assume that we're starting with 100 grams of sodium hydroxide dissolved completely in the water, together with 100 grams of barium nitrate dissolved completely in the water. Well, grams of mass does not react with mass. Its moles react with moles, or formula units in the case of ionic compounds react with formula units. Okay? In the case of organic material, molecules react with molecules. Okay? Or moles react with moles. Well, we have a 1 to 2 to 2 to 1 ratio. As I mentioned before, 1 to 2 to 2 to 1. But we have to know how many moles we have. We have 100 grams of each. To know how many moles we have to divide the mass by the molar mass. Well, molar mass is the grams per mole. How much does a mole weigh? So if we divide the mass by the molar mass, mass cancels out, and that leaves us with moles. So we'd be able to figure out how many moles we have by dividing each of these by the molar mass of the various compounds. Okay? So we have to figure out the molar mass first. Let's start with the molar mass of barium nitrate. Let's look at the Ionic Bond Disc Model to help with this. Okay? So we have one barium. Barium weighs 137 grams roughly. Nitrogen weighs 14 grams roughly, and oxygen is about 16. Well, 16 times 3, and 3 is 6. 16 times 6 is 96, and 14 times 2 is 28, plus the barium. The total weighs 261 grams, roughly. Let's do the same thing now with sodium hydroxide. It's one sodium and one oxygen, one hydrogen. So we have 22.99 grams for the sodium. Oxygen is about 16. Hydrogen's about 1. You add all that together, it's 39.97. So you can see we have all the molar masses there. We have 100 grams of each. We have the molar masses of each. So now we're going to divide it. Divide 100 grams by each of the molar masses. It'll give us the number of moles of each. So when we do that, we get 0.383 moles of the barium nitrate, and we get 2.5 moles of the sodium hydroxide. A lot more sodium hydroxide. We look now at those red numbers. That gives us the coefficients of the ratios between the various moles. If you notice, we need 2 times as many moles of sodium hydroxide than we do of the barium nitrate. Well, we have 0.383 moles of the barium nitrate, and we have way more of the sodium hydroxide. So the one that we don't, is a smaller number, is the limiting reactant. That's what limits how much we're going to be able to make. And then we have excess amount of the sodium hydroxide. There's leftover amounts, way more than what we need. So if you see there, we're going to need only 0.766 moles of the sodium hydroxide. So we have an excess of the sodium hydroxide, and we're going to have quite a bit left over. Now look at the ratio of the barium nitrate and the barium hydroxide. It's a 1-to-1 ratio. So if we start with 0.383 moles of barium nitrate, we're going to end up with 0.383 moles of barium hydroxide. So we figured out the number of moles of barium hydroxide now. The last step is to figure out how much mass that is, and we do that by multiplying that by the molar mass of barium hydroxide. So we need to calculate the molar mass of barium hydroxide. So if we look at this now with the barium hydroxide, it's got one barium, it's got 2 oxygens, and 2 hydrogens. We add all this together, we have 137 grams, and roughly 16 times 2 or 32 grams, and about 2 grams of hydrogen. We add it all together, it comes up to 171.341 grams. Okay, now we want to take that and multiply that by the 0.383 moles of barium hydroxide that's been produced. That'll give us our final total number of grams it's made. So when you multiply those together, it comes out to 65.6 grams, roughly. So we started with 100 grams of barium nitrate and 100 grams of sodium hydroxide, all dissolved in water, and the final product that came out of the solution is barium hydroxide, and it weighs about 65.6 grams material. The other grams are still in the water floating around with sodium nitrate. You should have learned from this how to figure out what the ionic compound formulas are, how to know if you balanced the equation correctly, what the ratios are between the various components, reactants, and products, how to figure out the molar mass of products, and how to then figure out the number of moles by dividing, and then figuring out the amount of products using those various ratios of moles, and then you convert that back into mass by multiplying by the molar mass. Stoichiometry does not have to be hard. It's just a series of small steps. There's a lot of steps, but just little teeny steps, okay? Now, if you want to know more information about the Ionic Bond Disc Model or the Ion flashcards, the links are in the notes below. Please subscribe. I would really appreciate it. It would help me a lot. If you want to know more about our company, the link to our website is there as well. Thank you very much. I really appreciate helping you. Thank you so much.